Look at what oxidation and reduction means. Typically, we use this term when we're talking about the extraction of metals. Extraction of metals. So when you have metals, we just find metals as metal oxides typically. We typically just find metals as metal oxides. This basically means that the metal has reacted with oxygen in the atmosphere. It's also like when iron reacts with oxygen, it forms an iron oxide. So oxidation just means the process of gaining oxygen. The process of gaining oxygen. I mean, it's pretty easy to understand from looking at the name, oxidation. You can kind of see the oxygen in that, and dation. It kind of sounds like you're gaining something, right? Oxidation is the process of gaining oxygen. So for example, you could have a magnesium gaining oxygen, so oxygen in the atmosphere. It's going to go to form the magnesium oxide. So magnesium oxide. But of course, we need to balance out our equation. We have 2 oxygens here and 1 oxygen here, so we're going to add a 2 here. So now we have the oxygens are balanced. We have 2 magnesiums and 1 magnesium here, so let's add a 2 here. So we've oxidized the magnesium. The magnesium reacts with the oxygen to become magnesium oxide. It's gained oxygen. That was really bad. It gained oxygen. So oxidation is basically just a process of gaining oxygen. So we can say the magnesium has been oxidized. On the other hand, reduction basically means the opposite, the loss of oxygen, the removal of oxygen. So for example, you could have the 2 magnesium, no, let me balance it afterwards, magnesium oxide. So we've produced the magnesium oxide, right? And we want to get it back into its pure form of magnesium and oxygen. Well, what would we do? We would get magnesium, and we'd also get oxygen, right? But oxygen is always diatomic, it always exists in pairs. So O2. Well, then we have 2 oxygens here and 2 oxygens here, so we can balance it out. 2 here, 2 magnesiums, 1 magnesium, so 2 here. Let me just write that a bit better. That's basically it. So the magnesium has been reduced because it lost its oxygen and it's been separated into magnesium and oxygen. That's basically what we do when we want to get metals, when we extract metals from Earth. Typically, more often than not, we'll find metals in this form. The metal will be a metal oxide because it will have reacted with O2 in the atmosphere and become a metal oxide. Basically, every single metal is going to be a metal oxide except gold, because gold is so unreactive, it doesn't even react with gold. That's also why gold is expensive, because it just keeps its form so well. So most metals will be a metal oxide, and then you'll go through this process of removing the oxygen and separating it out into magnesium and oxygen, so that it's a reduction reaction. I'll look at the extraction of metals in the next video. But reduction and oxidation can have a double meaning as well. There's another meaning to reduction and reduction, and that's what you'll learn in redox reactions. Redox reactions. You'll see why I've put 2 different colors for redox in just a second. I'll go in depth about redox reactions in another video too, but it's basically when reduction and oxidation occurs simultaneously in one reaction. It's basically when, say we have an atom, magnesium maybe, magnesium loses its electrons to become loses its valence electrons to have a full outer shell. So this might be the valence electron of magnesium. It might lose them to have a full outer shell, and it becomes a 2+ positive ion because it lost its negative electrons. Well, another atom, say maybe, I don't know what is there. Maybe carbon received, this isn't scientific by the way, I'm just making this up. 2-. The carbon might have received these electrons that the magnesium lost, because the magnesium can't just get rid of these electrons. It needs to give them to something. So you could have an ionic bond, and you might give the electrons to the carbon, and so the magnesium, I didn't explain what reduction and oxidation in this case means. So reduction in this case, reduction means the gain of electrons. Now I know this sounds super strange. You'd imagine reduction is reducing electrons, and oxidation, yeah, I also don't get why it's like this, and I also don't get why we're using oxidation and reduction for the gaining and loss of electrons. when it has nothing to do with oxygen, but just, yeah. Oxidation is the loss of electrons. So redox reactions is when it occurs simultaneously in one reactions, like with this, when the magnesium loses its electrons, and when it gives it to this. This will be the oxidation because it's losing its electrons, and one is receiving the electrons, so it's going to become the reduced. So the acronyms, the names just go opposite of what you would think, right? It goes against logic. That's why there's a common mnemonic that people like to remember. It's just called oil rig. Let me write that a bit better. That was pretty slanted, right? Oil rig. Basically just means not oil. Oxidation is loss, and reduction is gain. Oxidation is loss, reduction is gain. Basically, oxidation is the loss of electrons, and reduction is the gain of electrons. As long as you can remember this mnemonic, you'll be fine with reduction and oxidation. Just know that reduction and oxidation has double meanings. One can be for the loss and gain of oxygen, another can be for the loss and gain of electrons. And oxidation is loss, reduction is gain. But then for this one, for oxidation and reduction of air, it goes with logic. Oxidation is the gain of electrons, reduction is the loss of electrons. Just don't get confused. That's all I'll say. Thanks for watching this one on oxidation and reduction, and a slight intro to redox reactions.